The world is using a lot of energy right now. Most of it's coming from oil, gas, and coal.
Scientists say fossil fuels must be replaced by clean, renewable energy, or else
we will run into more problems of climate change, nuclear proliferation, and so on, and those could become very unmanageable and make the world a very unsafe and unpleasant place.
The biggest change will have to happen in the United States, which gobbles up a quarter of the world's energy and imports most of it.
We're so dependent on other nations, we really have no energy independence.
And Florida, with its summer heat and round-the-clock air conditioning, is one big energy hog.
We only really have electricity we can use to cool the state. In fact, in the summer, almost 50% of our residential electricity usage goes straight to our air conditioning. I'm Dr. Rick Driscoll, Professor of Ocean Engineering, Florida Atlantic University. Florida's unique. We have over 80% of our electricity produced from hydrocarbons. None of those hydrocarbons are produced in Florida, and we have to import all of our hydrocarbons to produce the electricity. If that supply is cut off, Florida is shut down.
At the SeaTech Research Center in Dania Beach, Florida, Dr. Rick Driscoll is part of a team of scientists who are working on a rescue plan for the state and the rest of the country. They think they've found a way to power the entire state by putting a massive turbine farm on the ocean floor.
It's going to be about 10 to 15 miles offshore of South Florida, and it's going to be moored in about 1,000 feet of water.
As director of the SeaTech Research Center, Dr. Manhar Danik keeps his eye on the big picture.
Ocean energy is a really important source of power that can be harnessed.
Offshore South Florida is the best location on the planet to harness ocean current energy. We've got the largest flow of ocean water coming by our coastline, pumping over about 8 billion gallons per second.
That flow of ocean water is the Gulf Stream, the steadiest sea current in the world. But before they can harness that massive energy, they have some huge problems to solve.
It's not just taking that technology that exists in these wind turbines and sticking in the ocean.
Their turbines will have to weather the most challenging conditions.
You've got surface storms that you can encounter.
Storm waves can reach a height of 50 feet. There are destructive storms deep in the ocean, too.
If the current shifts and the turbine can't keep track, or if the turbine essentially becomes unstable, it could actually crash into the sea floor.
And connecting the turbines 1,000 feet below the surface will be a difficult engineering feat.
We obviously can put people in space, put people on the moon, but it's much more difficult to put them even down a few hundred feet in the ocean to sustain them there. Pressure is probably your biggest enemy.
At sea level, pressure is about 15 pounds per square inch. At 1,000 feet below the surface, it is more than 450 pounds per square inch, enough to crush equipment like a styrofoam cup.
You're fighting marine life that may be trying to eat your material, such as barnacles that may be attaching to your control surfaces.
Corrosive seawater and barnacles can roughen the surface of the turbines, creating drag and loss of efficiency.
If we're not careful in the selection of the materials that we use to construct it, then the turbine could essentially corrode, or parts of the turbine could corrode to the point that they break or they seize up the motion of the propeller.
Second is the sealing issues. You don't want to have fluids leaking out or the salt water leaking into your underwater turbines.
Despite the obstacles, the payoff can be huge, catching the power of the Gulf Stream. For those who have known its secrets, it's been paying off for centuries.
It started off as a trade secret where companies would be leaving the Americas and having to get back to Europe. The ship that could get back there the fastest would obviously have an advantage. So the company that knew about the Gulf Stream would hop in the Gulf Stream, arrive there 2 or more weeks earlier. I think Benjamin Franklin was, the first person to actually look at the potential for harnessing the Gulf Stream.
But Ben Franklin didn't have a laser tank.
Hi, my name is Carl von Elnreiter, and I'm a hydrodynamicist working on the ocean energy current turbine. here at Florida Atlantic University.
Carl von Ellenrieder is testing the performance of different turbines in various sea conditions. Finding just the right design is tricky. He needs to find one with maximum efficiency and minimum turbulence. It's a vital step before SeaTech actually commits to mooring a turbine on the ocean floor.
The blades could actually have a lot of vibration on them and perhaps break because of fatigue.
To help photograph the flow of water across the turbine, 2 laser beams are turned into a wide plane using optic lenses.
This water is seeded with small glass beads, and by taking the 2 pictures of the particles in the flow and comparing how far the particles have moved from one image to the other, we can calculate what the velocity is in the flow around the moving object.
The experiment shows Carl that there's a problem in the water flow between the turbine and the housing, known as the nacelle.
So what we noticed was that there's a region of slower moving flow right behind the nacelle.
To adjust the aerodynamics, he's recommending a longer shaft between the propeller and the nacelle. But there are more serious problems. The crisscrossing arrows show turbulent water.
Just sort of like when you're flying in an airplane and you encounter turbulence, the airplane will jump by several feet. The same thing will happen to the turbine blades.
Equally important are tests on the environment where the turbines will live.
I can grab it off of there. I gotta hook that bottom piece on.
The SeaTech team is headed to the Gulf Stream today on a fact-finding mission.
Okay. Gonna throw a couple on there. We're just gonna let it down to near the bottom at 600, so we're gonna let out about 750 feet of line. And then we're going to just pull it up slowly, and it'll give us a temperature and a whole bunch of anything you could think of just about. Yeah, hang on. Okay, now it's on.
As it travels to the bottom of the sea, the sensor will gather data on pH, dissolved oxygen, salinity, current speed, and direction.
That shows you the current. See it?
What are we at?
A little over 350.
The results show that the Gulf Stream currents shift direction by as much as 20 to 30 degrees.
Currents have a natural meander. They're like rivers in the ocean.
Like kites in a shifting wind, the turbines will have to fly into the current, and their moorings will have to be flexible enough to allow that.
You can perhaps fly your system, change depth, go up and down, to hit the optimal velocity, so you're producing power at your highest efficiency.
The data also shows that the Gulf Stream is strongest 150 feet below the surface. That means the Kevlar and steel cables with electric lines inside will have to stretch diagonally to the ocean floor, some 3,000 feet. They'll be shielded so that no electromagnetic radiation leaks out. That attracts sharks and other fish, and they would chew the cable to pieces. Also, the turbines must be designed in a way that they don't hurt marine life. Very soon, this testing phase will end, and the SeaTech team will begin to put the ocean turbines in place.
We could see thousands of turbines out there producing up to, say, 6 to 7 gigawatts of total power.
That's 1/3 of Florida's total electric consumption, and they have other big dreams for the future.
On the ocean floor, you might see something that would look like, say, a small water plant or perhaps a clean refinery.
The scientists are now designing a system that will use the cold 40-degree water from the ocean floor to air-condition beachfront condos. They're also exploring yet another form of energy production.
We have the opportunity down there to generate hydrogen.
To make hydrogen, you need water and electricity. And once the turbines are in place, both of these will be available.
It will spawn up a huge new industry for Florida. This can have a huge impact, a global impact
The ocean is an absolute incredible source of energy. It truly has the potential to change the planet, to power the entire Earth. And we are at the perfect spot here in the United States, in fact in South Florida, to harness that energy.